Hey guys, we are back this week with a new kind of logic puzzle. It's called a Ken-Ken puzzle. And these might look similar to a Sudoku puzzle. They actually are similar to a Sudoku puzzle in some ways, but they have an extra layer of challenge because they have some math operations involved. So the first thing we're going to do is talk about how to solve them and the rules of solving them, and then we're going to practice solving one together. So we're going to start with this one up here. The first thing I notice is that there are 3 rows and 3 columns. That tells me which numbers we're going to use to fill in the boxes. Since we have 1, 2, 3 columns and 1, 2, 3 rows, we're going to use the numbers 1, 2, and 3. The second thing that you need to know is that we have cages inside this game board. So some of the lines you see are thinner lines and some of them are thicker, darker lines. Those thicker, darker lines are called cages. And just like you might put your pet in a cage to keep it safe if you leave the house, these cages keep numbers inside of them. And so this is one cage, here's another cage, here's another cage that's L-shaped, and here is a 4th cage. So we're going to put different numbers together inside those cages depending on the operations that we see here. So what these numbers tell you are the total of the number sentence, the answer to the number sentence. It could be a difference, like here where we're subtracting, we call that answer a difference. Here we're going to add, so we call that difference a sum. But what you need to know is that inside this cage, we are going to subtract these 2 numbers and we're going to get an answer of 1, a difference of 1. Over here, we're going to add the numbers in these 2 boxes together and we're going to get a sum, an answer of 4. This one is a little trickier because it's an L shape. That means we have 3 numbers, 1 here, 1 here, 1 here. We're going to add all those 3 numbers together to get a 5. So I want to look at this game board and decide, where should I start? Where would it make sense? Where can I prove, just like Sudoku, we want to prove where the numbers go. So I'm thinking, what are all the possibilities for adding to get a sum of 4? Well, I could add 1 plus 3, that would give me a sum of 4. I could add 2 plus 2, that would give me a sum of 4. I could also add 3 plus 1 to get a sum of 4. But guess what? These 2 use the same addends. Both have 1 and 3 added together. So they're kind of the same. This one doesn't really mean anything because it has the same addend, 2 plus 2. And so this one I don't even look at because guess what? I cannot put 2 2s right there. That breaks the rules that we learned when we learned how to play Sudoku. Remember, every row and every column has each of these numbers, 1, 2, 3, only one time. So what are the ways that I could get 4? I could put 1 here, I could put 3 there, or I could put 3 there, I could put 1 there. I don't know quite yet which one goes where. So I'm just going to give myself a little clue marker that I think in this box it's a 1 or a 3, a 1 or a 3. Now, using my logic, if this is a 1 or a 3 and this is a 1 or a 3, what has to go there? If 1 and 3 are already used, it has to be a 2. I know that for sure, I can prove it. So now I'm going to look at this L-shaped cage. If this one is a 2, think about this. 2 plus a number plus another number has to equal 5. So 2 plus something else equals 5. What can I add to 2 to get to 5? I can add 3. So that tells me that these 2 boxes, if I could make a new cage here and say that it would end with an answer of 3 after I add. Now, how do I get 3? Here are the ways I get 4. But if I wanted to get 3, I could take 1 plus 2 equals 3, or I could take 2 plus 1 equals 3, and that's it. There are no other ways that I could get 3 using the numbers 1, 2, and 3. So one of these has to be a 1 and one of these has to be a 2. So let's think, if I already have a 2 here, could this be a 2? Nope, because that would be 2 2s in the same row. I can't do that. So this one has to be the 1, and this one has to be the 2. All right, so we filled in this cage. We still don't know about this one because the only thing we filled in is a 2, and that doesn't really help us much there. I have the same situation here where I have to get 4, and I know from doing this work already that the only ways that I could get 4 are adding 1 and 3 or 3 and 1. So I can add a little note up here for myself, 1 and 3 or 3 and 1, but look, I've already got a 1 and a 2, so what has to go there? A 3 has to go there because I can only put each number in each row one time. And if I've already used a 3 here, then this one has to be a 1. And now I'm cooking because I have a 1 and a 2, and what would have to go there? A 3. And guess what? I'm only going to use this one just to double check my work. But because I already have these 2 filled in and just 1 left open, I can use my logic to figure out what goes there. So if I have a 1 and a 3, this would have to be a 2. And I have a 1 and a 2, and that would have to be a 3. Now, if I take the bigger number minus the smaller number in this cage, do I get a difference of 1? Let's check. 3 minus 2 does equal 1, so that works out. That's good. And I already checked this one. 1 plus 3 is 4. That's correct. 2 plus 1 is 3 plus 2 more is 5. That works out. And then what has to fill that box in? It's a 1. And I already know 1 and 3 equals 4, so that works out. This is how you solve a Kin-Kin puzzle.